大家晚上好，欢迎大家准时来到第265期原理开放日，我是今晚的主持人月游，很高兴又和大家在周二的晚上见面了。本期的原理开放日呢，将带大家了解 Lava Network，这是一个为 Web3 的去中心化 RPC 层提供支持的加密市场。Lava 呢为 RPC 数据访问提供了一个无需信任的市场，该协议管理点对点和私有供应商应用程序的配对，确保高质量的 RPC 服务。同时围绕所服务的数据达成共识。当中心化的节点基础设施弊端越来越明显，区块链基础设施的其他部分也正在朝着去中心化方向的发展。在这样的前提下呢，我们一起来听一听来自 Lava Network 的 Ethan 他们的具体解决方案吧。Hello everyone, welcome to our first open day. I'm tonight's host, Koana, and I'm happy to see you all again on Tuesday nights. In this episode, we will be looking at the Lava Network, the crypto market which powers a decentralized PRC layer for Web3. Lava powers a trustless market for PRC data access. The protocol guards over peer-to-peer and private provider. Application pairings. Ensuring high-quality PRC service while creating consensus around the data survey. As the drawbacks, our decentralized node infrastructure become more apparent. Other parts of blockchain infrastructure are progress decentralized. Let's listen to Ethan from Lava Network and their specific solution.
Hey everyone, my name's Ethan and I'm the head of marketing and community at Lava Network. Today, I want to talk to you about how do we move towards decentralized access to Web3. Let's begin. Why is decentralized access important? And what does it actually mean to access Web3 in this context? Well, at Lava, we believe that blockchains enable radical new ways for the exchange of value and for social coordination at a grand scale. And blockchain data is integral to the system. Therefore, we believe that blockchain data should be trustless. You don't need to ask anyone if the data is legit, is verifiable, is real. It should be universally accessible. Anyone should be able to use the data and own it for themselves to exchange value in this new financial system. And it should always be available. If you don't have access to the data, you don't have access to this new system. And therefore, the data being always available means that anyone can participate whenever they want to. Our mission at Lava is to build the open standard for blockchain RPC and APIs. And these are two terms which are super important to understand what it means to access blockchains. So before we dive in, some basics that we need to explain so that everyone's on the same page. What is a node? What is RPC? And why every Web3 app needs access to blockchain APIs. Blockchains are magic decentralized databases made up of each node, and where each node stores a copy of the state of the ledger. Anyone can run a node in order to read and write to the blockchain, to the ledger, without needing to go through a trusted intermediary. And that means that you don't need to trust. You can verify for yourself whether the blockchain is coming from whether the data is coming from the blockchain. And whenever you want to send data to the blockchain, you don't need to go through or ask permission from any third party. This is the basic premise of what a blockchain is. And so RPC stands for remote procedure call. And what it is the essential protocol for developers to access blockchains and the data contained within blockchains. So applications will make RPC calls to RPC nodes. And an RPC node is just a blockchain node which has opened itself up to allow RPC calls to be accepted by it. And so it can serve responses to an RPC request. So an RPC request might include ETH get balance, which is get the balance of an address on the Ethereum blockchain. It might be an ETH send transaction, which is to send a transaction to the blockchain. Or it might be something like estimate gas, which is, as you might imagine, estimating the gas it would take to make a transaction. And there's a whole host of other RPC calls, which are super important for just using a blockchain, or as we just said, accessing Web3. Finally, to get data from the blockchain, you need RPC. To send transactions and data to the blockchain, you need RPC. It's the fundamental language of blockchains. The problem today is that Web3 access is broken. You need a separate provider for every chain. The data that they provide is unverifiable and inconsistent. The access is not very scalable, and also it's not very private. You're using providers, companies that run nodes, RPC nodes, and they can store all the data that you give them. They can profile you based on the queries, and we'll explore this now. So what does it mean that access to Web3 is fragmented? Well, it means that across every ecosystem, whether that's Ethereum, Cosmos, L2s, Celo, Avalanche, Solana, you might have a different way to get data from that blockchain and to send data to that blockchain. So you might use what are called public RPCs or public RPC endpoints. These are essentially nodes which have endpoints, i.e. they've opened themselves up to accept RPC calls, which are run by chains themselves. So Solana or Polygon or Celo might actually run RPC endpoints and make it free and open to public. So any developer can get and send data to the blockchain through that endpoint. It's not very sustainable because it is open to everyone. And so you don't get a lot of scalability because what happens is the chain has to rate limit how many requests a developer or an application can make per day. The other type of provider is an RPC provider. And with these providers, they're centralized. They are Web2 businesses that run nodes for you and allow many applications to connect to those nodes. So there are pros and cons, but one con is that you get a lot of vendor lock-in. So if you use a provider on one network, you have to use another provider on another network, and there'll be contracts and procurement processes, and you won't have the flexibility of being able to switch to a new provider if your provider is bad. So that's just one of the downsides of having a centralized RPC provider, but there are some that I'll speak to in a second. And then finally, you can run your own node. So as I said at the start, the fundamental promise of blockchains is that anyone can run their own node and join the blockchain. But I'll ask you guys now, how many people run their own nodes or know how to run a node, in fact? This is something that is reserved for more technical folks, and it's not very scalable or practical because it requires maintenance and sort of manual scaling of the traffic that each node is able to receive. So it's not a solution for the long term. And think about this across all blockchains. If we're imagining a multi-chain world, it's extremely fragmented and there's no single perfect solution. The Web3 access today is also trust-based. So you might use a centralized provider and the data integrity is non-existent, right? So you don't know whether the data is accurate, or sometimes the data isn't accurate. Sometimes the data is inconsistent, which means that if you compare it to another provider or to another node and the response you get from them, the data might be different. The reason for this is because a blockchain is a decentralized network of nodes. So every node has, a lag in terms of when they receive the latest state, and they may not have updated yet. They may be a few blocks behind. So the data that you get may be inconsistent or not fresh. Complete, is the data actually complete that you're getting, or is it only a part of what you wanted? And also attribution. Is the blockchain actually coming from the blockchain? Is the data actually coming from the blockchain? Sorry. When you use a centralized provider, that's something that you can't be sure. And essentially defeats the whole point of blockchain. So imagine you're a wallet company or you are the user of a wallet, you want to make sure that the data you're seeing, the balance that you see in your wallet, is actually correct. And this is something which is a little bit, is fundamentally trust-based at the moment if you use a RPC provider, which most apps do use. Thirdly, offerings right now lack privacy. So you can run your own node, but as we said, it's not really a solution because it's impractical. If you use a public RPC or a centralized provider, these solutions lack privacy, and they can actually profile a user based on the queries they make. They can take that data and sell it, just like Facebook or YouTube. They can sell that data. And then finally, you can actually censor someone by their IP address as well. And so with the recent Tornado Cash situation, much of the US was told that they could not access Tornado. And if they did, then it would be a crime, right? Because Tornado Cash was put onto the OFAC sanctions list. And so how is that enforced? That is enforced by IP address tracking. So this is not an advocation of non-compliance. We should comply with regulations. However, what it says is that if you want private transactions for harmless reasons, then this is a solution which isn't currently available at scale today. And then finally, you have centralization, which we'll talk about again in a second. But there are many reasons why centralization isn't great for this sort of key infrastructure like RPC. One, you have a single point of failure. If you use a centralized provider and they go down, then your whole application will be redundant and your users won't be happy. And recently in Venezuela, Infura, which is a famous RPC provider, they actually blocked access to RPC nodes for Venezuelan citizens, for some Venezuelan citizens, which meant a lot of them couldn't access MetaMask and couldn't access Web3 for a little while. It is also permissioned. Like I said, these entities have to comply to laws and local laws, and they also give you permission to actually use their business and their service or not. So this is something which goes against the whole point of Web3, in that Web3 should be permissionless, anyone should be able to use it. And so today that is not true. And then finally, there are long-term misaligned incentives. What this means is that right now, providers may want to give the best service they can in order to capture and onboard as many users as possible. But in the long term, because of the incentives of profit, you see that these providers may start selling your data, which may impinge upon your privacy. They might start charging high prices, and things like this. So similar to how networks like Facebook switched the relationship between the network and the user from value generative to value extractive, so too might providers in the future. So RPC today isn't a public good. Now, centralization is an important topic to talk about because I just mentioned why it has its downsides, but it's also a two-sided coin, right? So centralization can be good. You see here examples. Centralized providers can be innovative because of the competition and also the nature of their closed source code. They can also be super easy to use, right? They're incentivized to make great products. You see a lot of really great centralized products. And before Web3, we all use Web2 products, and most of us were quite happy. So this is the nature of centralization, and centralized providers aren't necessarily to be demonized. However, as I mentioned, there are certain drawbacks which may, one, defeat the whole point of Web3, two, might make it a little less performance than another solution might be because of the single point of failure. And also three, you might have to trust the data that they provide, and it may not have as much data integrity as it should do. So it's pros and cons. This is a diagram which shows you how an application would connect to a blockchain via an RPC provider, which may run several nodes, for example, on the Ethereum blockchain. Now, I invite you to think about what if. What if there was a way to automatically connect to a new provider if yours was unavailable? What if you could use multiple providers at once and have no dependency on a single vulnerable provider? What if connections and sessions with providers were default private? What if providers are always incentive aligned and they will receive max rewards only if they give the best service? What if data integrity was verifiable and transparent? And what if such a system was universally accessible? Well, that is what Lava is building. Lava is a decentralized network of top-tier API providers through which developers can access any blockchain with just one subscription. There's no need to have different use cases, different providers or RPC nodes or public endpoints across different chains. You can use the one standard for accessing Web3 just by using Lava. So how does it work? This is a diagram of what the situation will look like with Lava. So the application will talk to multiple providers, and it will make RPC calls through the Lava protocol, which is decentralized. The Lava protocol would route their relays to independent RPC providers, which might include Alchemy or Infura, which are centralized providers. And then they would send back RPC data to the app. And it's important here to note that the RPC via the Lava protocol is a whole, there's a lot going on there in terms of the providers would stake on the Lava network, which means that they're incentive aligned and they provide great service and they'll be rewarded for that. The application would pay through the protocol and the payment will be settled on the blockchain. There's a check, a random check, which is optimistic. So providers, their responses are sampled randomly, and if it's incorrect or there's a conflict, there'll be a vote on chain, which would then reward the correct voting providers. And so there's a lot going on there, which means that the quality of each provider is incentivized to be always the best it can be, while still keeping the network decentralized in a way that means there's high uptime, there's privacy, there's a lot of scalability as well. So this is Lava network in a nutshell. As I mentioned, there are a few different features of the protocol and network. There are quality of service rewards, which means that providers are incentivized and rewarded according to their quality of service. They get more service if their quality is great. They get more payments if their quality is great. And that's scored across speed of response, accuracy, and also uptime. There's also decentralized access. So with other decentralized networks, the developer may have to access the network through a centralized gateway, which again defeats the whole point of the decentralized network. And so what Lava is building is a decentralized alternative whereby you can directly interact peer-to-peer with the network without going through a middleman. Okay, so Lava is not a middleman. You can think of it as like a coordination engine in order to pair applications to providers. Thirdly, any chain, any API. Like I said, Lava is the open standard for blockchain RPC and APIs. So every chain, every API is accessible through Lava. We just need someone to propose it as a spec, and then the open source contributors will add it on to the network. We have consensus-based data integrity. As I said, the responses from providers will be sampled randomly and probabilistically and compared to other responses. So if there's a conflict there, there'll be a vote, and the right answer will win according to a consensus mechanism. We'll have scalable network redundancy. So as is a decentralized network, and the incentives are that providers should join so they can serve the customers. What it means is that it's super scalable. So it's technically scalable and also economically scalable, which means that your service should have very little downtime, if any. And finally, the connections between the app and the providers are totally private. They are random, and they are scrambled. Your queries are scrambled to different providers, meaning that the process is introduces total privacy. We have a few different products. Number one is the Access SDK. You can see here a short GIF of that. It's built for developers by developers. We wanted to make it as easy to use as possible. We wanted to have a quick, intuitive way to use Lava and access Lava without needing to make it super difficult or slow or very unusable like some decentralized products are. And so here you can see a few lines of code and you're participating in the network. We have the gateway. So the gateway is sort of like the little brother to the SDK. It's for any products that are still testing or still in testing stage. So it's not for production grade applications, not for enterprise, not for actually products that are to be used, but it's for when you're testing your application, you can use this, super simple to use. And again, you can access all of the network through it. Thirdly, we have Lava Info. Now, Lava Info is a analytics page where you can see information on all of the providers to see how the network is doing. Are the providers fast? Where in the world are they based? At a high scale, and you can see exactly what the health of the network is at all times. And finally, we have Big Dipper. Big Dipper is essentially our block explorer. So again, you can see how many tokens are staked, how many providers are on the network, what is the usage like. You can see transactions and payments between providers and developers. And it essentially acts like a block explorer such as Etherscan. So 4 super cool products, which we couldn't be more excited to bring on board. We're already in testnet, which I'll explain in a second, but we do have testnet right now for the gateway. And so would love for people to come and try it out if this is interesting to you. This is the chain list that we are serving, or actually some of the chains that we're serving. So we already offer access to Ethereum, Starkware, Arbitrum, Juno, Stellar, Osmosis, Cosmos Hub, and many more to come, and a few more actually in addition to this since I made this presentation. As I said, Lava is chain agnostic. We're building to be the one-stop shop, the place to get any chain, any API with just one subscription. It's the easiest thing in the world, and we really do think this is providing a vital service to all of Web3. The roadmap is as such. So we have the MVP testing, which was last year, which is a private testnet, and our testnet launch is coming soon as well. Actually, these dates might be a little bit wrong. The testnet is coming this quarter. Okay, so Q1 2023, we're launching publicly, and you guys will be the first to know this. We'll be launching our gateway, our SDK as well. So looking forward to seeing how you guys test that. Keep an eye on our Discord and our Twitter for announcements there. And later this year in H2, we'll have the mainnet launch. The mainnet launch will be for the actual full-fledged version of Lava, where enterprises and large adapts can also use us to scale as far and wide as possible. But it's a super busy year ahead. And as I said, the Discord is the best place to go alongside our Twitter to follow for any updates. Finally, Lava's testnet is open right now. We've already announced in private to our community on Discord that they can access the testnet. We haven't made it public just yet, but we will very soon. So if you listen to this thinking that you want decentralized and accountable Web3 APIs, you want fast, reliable, high uptime service, Lava is the place to go. We'd really, really love for you to come on board and to give feedback and to play around with our pixel art, which you can see a bit of here. So yeah, please jump into the Discord and we'll see you there. Thank you very much, guys. I'll speak to you guys soon. Bye-bye.
好的，非常感谢 Ethan 的精彩分享。Lover 是一个公共产品，它创造了一个所有人都可以访问的 Web3，以正确的方式构建 Web3，也正是他们对于区块链访问的愿景。当然，如果后续大家对于 Lover 的进展感兴趣，以及想一起构建更好的 Web3，欢迎保持关注他们的最新动态。好的，那以上就是本期原力开放日的全部内容了。我们会不定期为大家提供高质量的内容呈现，期待下次再见。Okay, thank you so much, Ethan, for your wonderful sharing. Lover is a public good, creating a Web3 accessible to all. Building Web3 the right way is also the reason for blockchain access. Of course, if you are interested in Lover and want to work together to building a better Web3, stay tuned for updates. Okay, that's all for this first open day. We will provide you with high quality content from time to time. Look forward to seeing you next time.